All right, welcome back to the course. We're coming closer to the end. I hope you are enjoying the hands-on work using the methods to PSS case that you have chosen. You have studied from me 3 methods. Layer method and FMEA and QFD so far. And through that, you have described the important elements by the layer method. And then you have addressed uncertainty through FMEA. And you have incorporated customer values through QFD. Right? And through using those 3 methods, I think you have some ideas for improvement of your PSS, and I hope you are in the phase of sort of diverging ideas and selecting really good ones among the possible improvement ideas. This is a situation when the interdependency matrix is useful. Okay? So in this lecture, you will learn first, exchangeability between product and service. I will explain that later very soon. And then the interdependence. That's a precondition for exchangeability. Okay. I will now zoom out from PSS to businesses in general. There was a big study focusing on failures in a society. Any kind of failure, like traffic accident, computer system failure, any kind of failure. The study was conducted in Japan, and as you see, there are 3 categories here. Software on the left-hand side, hardware, and service. Those 3 refer to the industrial sectors. So software sector, hardware sector, and service sector. And each bar is divided into the conditions where the failure occurred. Now I'm focusing on the yellow portion. This study, or this particular paper, 2009 by Nakao et al., used a design theory, design methodology by Namsu, axiomatic design. But let's leave out the complexity of the method. So as I said, so we are looking into the service business, and the majority of failures that occurred in the service business is caused by the condition where services are unrealized. So that is sort of the insight obtained thanks to the use of axiomatic design. So what unrealized service means is typically you are in the service business, and you use, for example, a product. And you want to execute some defined services, okay? But you cannot sort of perform the services in such a way that the customer value is realized, or a certain function is realized. That's the situation where big failures occurred, according to the study. This may sound very stupid, but this is how it is. We hear from time to time an accident happened. Just a few hours ago, I read an article on the helicopter and aircraft crash in US. It happens. And this study showed that in the service business, most of the majority of the situations include unrealized service. This study didn't focus on PSS, but thinking about all of what you learned in this course so far, product, service are interrelated, and making sure the interrelation between the product services are fully utilized is very important in PSS design. So this big portion of failures indicates that such a importance of seeing the connections, interrelations between the product and services in a system. Okay? Did it make sense? So that was an introduction. And so now the question is, we need to find such an interdependency between a product and a service in the system that you are looking at. And once you find such an interdependency, then I'm recommending you to use the exchangeability. This is the term that we developed, we coined. The definition of the exchangeability is a feature of being able to exchange efforts for service and physical product design to improve the overall PSS characteristics independent, interdependent products and service. You have seen this tree structure in the lecture of FMEA. So the same kind of tree structure is what you're looking at. And these small circles represent functions realized by either service activity or a physical component. But the aim of these functions is to realize a certain customer value. No? Right. So look at the relation described here. So that part shows that a certain function, a small white circle, is realized by the service activity or the physical component. And if this relation exists, we say that the efforts for the service activity or physical component can be exchanged. And we say that there is an exchangeability. It's a little bit abstract statement and discussion, so I will give you the most simple, I would say, example. So service and product, right? And both of these can serve a certain customer value. For example, a customer, let's say, wants some information to answer his or her question, okay? And then that customer value can be met either you as a provider providing a help desk service or, for example, some kind of manual. It's a product, right? So both of these can be a measure for that customer, to meet that customer value. And here, you as a designer can choose which one you adopt in your PSS. Okay? And in some cases, you may want to choose both. And depending on a specific situation, you will choose. So that's also possible. The choice can be determined in terms of several aspects. One could be the economic viability of you as a provider. So you may want to choose the option that is most cheapest one. Or you may want to use the degree of customer value as a choice criterion. So you may want, then in that case, you will choose the option that provides the highest customer value. So here, you can choose in between different options. So that's what exchangeability means, okay? And from now, I am giving you 11 examples. Each example shows such an interdependency and also implying exchangeability between products and services, okay? So the first example is from washing machine, and those examples are all taken from scientific papers and building upon industrial cases, okay? So, according to a certain research work, a washing machine was used in the PSS context, and the washing machine was redesigned for an easier repair. So this is an example I think we have touched upon in the course so far. And we see dependencies. Product, in the case, the washing machine depends on the service, in this case, repair. And the repair performance depends on the product design. So therefore, the direction of the dependency is bidirectional, okay? And earlier we discussed product design parameter categories, service design parameter categories, and in this case, we can see the service design parameter belonging to labor intensity, one of the service design parameter categories. And in this case, the relevant product design parameter category is serviceability of the washing machine. And by addressing a balance between the two, you can contribute to increase the resource efficiency. So that's the aspect. Did you follow? I will use exactly the same scheme in the upcoming examples. So you see, first I will show you the sector and then the very brief description of the example, and then I will use this scheme. And I'm sure that you will get even more familiar along the examples. So another case, pump. In this case, it's interesting that specific services, in some cases, require specialists, not ordinary staff in the service, but service specialists. And in this case, and also, the product needs to be serviceable, and depending on the depending on the personnel who executes the service, the product design must be ready for the service to be executed. For example, if if a product is designed in such a way that every user can inspect and repair and so on, then capability required for the services is low, for example. No? One example is like exchanging batteries. That can be done every layperson. And so the capability of the service technicians depends on the serviceability of the product, right? And in this case, making a good balance between the two contributes to the product service system design parameter availability, right? Okay. Continuing with the same product, serviceability of the product, again, influences on the responsiveness of the service, in this case, actual service time, which we discussed earlier, responsiveness. So the responsiveness depends on the serviceability of the product, so that the availability could be improved. Right? Next case from construction machine. The product design, in this case, the research work addressed the specification for the hydraulic system of the construction machine. That specification for the product design depends on the information coming from the service execution. Next case, jet engines in aerospace. It's quite simple. Cost of overhaul, that is a service activity, depends on product design, so that the overall cost can be influenced. Vacuum pump, again, service cost against product cost can be handled so that the overall affordability or the price can be influenced. In the case of forklift truck, labor cost of the service technicians can depend on the product design, and in this case, automatic monitoring device was considered to be put into the forklift so that the service labor cost will be decreased. No? Affordability. Next example, again, construction machine. The maintenance task depends on the information transferred from the product design. Availability. And next example, again, jet engines and aerospace. Product design depends on the information from the information that can be obtained from the service activities. In this case, deterioration. So in this case, product design products were upgraded in terms of design depending on the deterioration, I mean the product condition from the that can be obtained from the services. Right? So two more examples. Medical equipment case. In this case, the devices, when the medical equipment devices get older, then there was a need of more education of the technicians, hospital technicians and doctors in terms of training in order to increase the knowledge, their knowledge for how to deal with the medical equipment device. So therefore, and also, sorry, in this case, they found that better training, better education on the service technicians increased the product condition maintenance in terms of maintenance. last example, which I already told in earlier, soil compactor used in the road construction typically. The product was changed in that case in terms of the product surface, and therefore the deterioration of the surface of the product influenced the speed of the deterioration, influenced on the frequency of the services. So because they changed the soil compactor surface, therefore the frequency of the service was prolonged, and thereby the product life extension was realized. Okay, so I'm quite sure that you see this kind of interdependency between products and services in your own PSS case. And so here, what you should do is to find such interdependence and consider the possibility of exchangeability. So meaning that if only a product is used, then consider service to be implemented to replace the product component, okay? To realize the same customer value, and the other way around as well. If you have both product components and also service activities, then consider improving the balance of the efforts put into the product components and service activities. Okay? So those are the things that you should consider in improving the product service system. No? Okay. So far, is it clear? Okay, good. And so now the question is, you have a product service system, and you have described product design parameters and service design parameters. The question is, which design parameters have interdependencies in between products and services? Because there are interdependencies, as I have been through different examples, but not all design parameters have dependencies from the other side. So in this picture, the red lines show the existence of dependencies between product side and service side. Okay? And there are many parameters without the red line. And it's very time consuming if you need to check each and every design parameter from the product side and also same from the service side. It's very time consuming. Right? And you need to consider every single time. So that's why a recommendation here is to lift up your thinking level from the instance level to the class level. So you move yourself up to the abstract level where the service design parameters and product design parameters are possible to represent as class parameters, categories. Now you can decrease significantly the number of parameters you can think of, because I exemplified earlier the service design parameter classes. Okay? In that particular slide, there were only 7 or so. Okay? And in the same way, product design parameters are not that many if you are on the class level. Okay? So therefore, the number of combinations can be significantly reduced. So the computational effort or analysis effort is much, much more lower if you do it on the class level, right? So what we have developed and you have access to is this matrix. This is built upon 42 cases that were reported in literature, and then this matrix tells you there are some interdependencies between the product design parameter classes and service design parameter classes. These gray cells mean that we haven't found a dependency between the combination. No? And on the other hand, white cells mean that at least one scientific work has found such an interdependency. Right? If you look at the service design classes, 7 classes, these are maybe a little bit modified from the slide that I showed you earlier, but more or less the same. For example, responsiveness, service technician capability, labor intensity, frequency, and so on. And for the product design parameter classes, here recommended are serviceability, affordability, information transferability, upgradability, and temporal functionality. And in the matrix, you see the direction of the dependencies. In the previous 11 examples, you saw the direction of the dependency with the arrows, no? With the direction of arrows. But here it's indicated by PUS, PBS, or SUP. It's a matter of representation. The same information is conveyed. Okay? And one more aspect shown on this matrix is the PSS parameter, PSS design parameter classes are also shown in the matrix. Okay, so you have access to an Excel file that shows exactly this matrix as well as the 42 cases that were the base to come up with this abstraction. Okay, and your task in the project work is to look into this and utilize some of these interdependencies. Huh? Any questions? Do you have questions? Yes, please.
Sir, so if you are developing service parameters, then there is a big component of unrealization. There are many things which can't be realized beforehand. So that makes it very experimental by nature. That we have to experiment and find what unrealized aspects are there. And sir, on the other hand, you showed that after the slides regarding design fixation and versus design limitations,
Yep.
there was a slide where it showed that most of the time was spent on problem space development,
Yep.
and within that system development.
Yep.
Then sir, if system is unrealized, how can we spend most of the time in system? We have to develop the product, bring it to the market, and then like the graph for US product development where it was a spike after the product was developed. It would be like that only if we like follow the route.
Yeah. there were many aspects coming from the earlier part of the course, and I can provide you with some additional information as answers. So let's take the picture of front-loading example, the failures happening after the launch of the offering. All of these methods and tools and support are meant to help designers to decrease that, preferably eliminate such a failure that occurs after product launch or PSS launch on the market. Okay? What's the rationale? Because this sort of knowledge base can help designers simulate what will happen when PSS is offered and when customers are involved in getting the results from the PSS offering. Okay, so that's one thing. So did you see the connection between this one particularly and the failures happening after the market launch? Okay, that's number one. And unrealized one, which I mentioned at the beginning of this lecture. So with this matrix, what unrealized service means is, let's say, okay, let's say there is a PSS, and the product used in the PSS has an important feature that is information transferability. For example, the product was expected to show some information. I don't know, product condition, for example, battery, power left, or things like that. This matrix shows that has a dependency to 3 service design parameter classes. For example, labor intensity and others. And then let's say a service technician is given an instruction from his or her own company, service provider. Okay, and they have limitation in work hours or work efforts, whatever. And if this knowledge base is well used in design stage, and if this information transferability of the product and labor intensity was well integrated, then the service technician can fulfill the job effectively. But if that interdependency was not fully considered in PSS design, it's possible that the service technician cannot do the job. For example, I don't know, they may have limitation in work hours, or they are maybe located in too far location, things like that. So the thing is, this kind of knowledge base, based on the previous cases, indicate, please do consider these interdependencies and take those effectively into account in the design. So that's the sort of message of this slide, and designers should consider that kind of thing in designing phase. No? What else did you say?
Actually, what?
Yeah.
So by using these tools, the
Yep.
unrealized part will be reduced.
Yeah, that's one big purpose. Yes. Yeah. Yes, exactly. So that's why I picked up that research study result at the beginning of this lecture. So avoid unrealized services, and so realize the services well combined with the product components. So these are the messages. Good. Thank you for a question. More question? Okay. No. Yes.
So in each of those cells, what do resource use, availability, and outcome mean?
Okay. So resource use, outcome, affordability. etc., are attributes for the PSS. Okay, so meaning that, yeah, let's say using the, yes, continuing the previous example, in that example, what is affected in the PSS level, overall level, is an outcome, because in that particular case, some services can't be executed. Therefore, a certain outcome is not realized on the PSS level. And then it may be affordability in another case of this kind. Those PSS design parameters, or high-level descriptions, are also coming from the cases that we found in scientific papers. So that's what we also categorized those aspects on the PSS level into a quite small number of classes. I think there were only 5 or so. So that you as a designer can only see this high-level description, abstract description.
So you mean those for example, outcome and affordability are the underutilized areas?
Yeah, you can say that as the PSS features. Okay, so some information of the Excel file that you get access to. It's a simple spreadsheet, and then if you open one sheet, then you will see this kind of matrix, because you have a specific PSS case, and therefore you should be able to describe service design parameter instances. Okay, instances mean that specific design parameters from the service point of view of your PSS offering. Okay, so that's one thing to do here in this column. And then moving to the next column, it's a description of the class. So what you should do, there are options. It's a pull-down menu. And if you, for example, say service logs as one service design parameter instance of your PSS, then you should choose one class that is information transferability of the service. Okay? And another example is customer training as service design parameter instance. Then you should choose capability of the service design parameter class. The same task applies to the product. Okay, you describe the product design parameter instances, the specific concrete design parameters of the product in your PSS, and then choose the design parameter class, one of them. One of the alternatives that you see from the Excel file. Once you have chosen the service design parameter class and product design parameter class, then the possible relations between the product and service will be indicated in this matrix. This is a sort of simple software developed for academic purpose, so it may not run perfect, but the idea is you describe the parameter instances, and then you are to choose class parameter, and then the according to the 42 cases behind this matrix, the interdependencies are suggested. That's a sort of automatic process. And what you should get from this matrix is, so now here, okay, so this parameter and this parameter has an interdependence. And then you as a designer should consider the possibility of using that interdependence. No? Either replacing the effort of the product with the effort of the service, or making a better balance between the two. Okay? So far, is it clear? Okay. Then I will give an application example, which we worked with a company producing elevators that are, those elevators are special ones because they are used only in the towers for windmills. It's very specific one. No? Business purpose, quite special elevators. And the company wanted to optimize the product and service throughout the elevator life cycle, right? So the procedure we applied for this case is this. The core part is step 2, 3, and 4. So getting the critical design parameters of the products and services. Okay, that's step 2. And then step 3 is find potential interdependencies between the product and service design parameters by using the knowledge base that I have explained. And step 4 is for the generating improvements based on the interdependencies found in the previous step. Step 1 and step 5 are meant for an assessment of the current offering at step 1 and improvement offering at step 5. And then in this specific study, we used life cycle assessment and we measured CO2 emission against the status quo and the improvement offering. Okay. And first, this slide shows the result of the life cycle assessment, CO2 emission. We calculated CO2 emission of the elevator usage for the wind turbine tower, and then we found that the use phase of the elevator emits 82% of the total CO2 emission of the life cycle. And interestingly, the emission 82% comes from the not through the electricity used for moving the elevator cargos, but because of the stoppage of the wind turbine when the maintenance takes place for this elevator. Okay, so there are maintenance activities for this elevator. That's the service by this elevator manufacturer. And when maintenance takes place, because of the safety regulation, windmill must be stopped. Okay. In that situation, renewable energy is not produced, right? So renewable energy that can be produced through the wind turbine can't be produced because the windmills don't rotate during the maintenance process. In the assessment scenario, we assumed that the lack of producing such renewable energy is compensated by the other means, such as fire plant, electricity production, and so on, which is emitting much more CO2, as you know. So that was a little bit the background of the calculation. Anyway, what we got as one important message is the the time for doing maintenance for the elevators is so important, because if the time is shortened, then the windmills are operated longer, and thereby CO2 emission as a whole in the system will be decreased. Okay, so that's the sort of logic, and therefore we learned from the assessment of this case that this PSS, in terms of the PSS design parameter, availability at the high level is very important. Availability of is the very important parameter. Then we used the matrix. We first searched where availability exists in the matrix. Okay, as you see in the yellow marks. And we asked experts who are designers of this product and also services. And according to the experts, these three red ones are relevant in this specific case. Right? It is natural because this matrix and the knowledge base are built based on a number of different cases. And that includes a number of sectors coming from obviously outside the elevator service, okay? Pumps and forklifts and engines and so on. So this naturally happens. So the experts say that these are the three relevant interdependencies. So now designers looked into the product design parameter classes and service design parameter classes. And we asked again the experts of the product and service of this offering, and what are product design parameter instances of this elevator. For example, actual lifetime, component durability, internal sensor system availability, and so on. We did the same for the service design parameter instances. So then, as this table shows, we combined the product design parameter instances and service design parameter instances, and designers came up with improvement ideas. And one of them was reducing the time for performing the maintenance through, I think, through improving the service protocol, and also using the predictive maintenance. Then experts said that currently the maintenance typically takes 2.5 hours, but that can be reduced down to 1, and thereby the maintenance time can be significantly reduced, and hence the CO2 emission of the system can be reduced accordingly. And then, by the way, very much significantly in this case. There is another idea came up with this combination and also brainstorming. That one was product life extension. Okay. So, so meaning that in the this application, designers received the output from the knowledge base, and they brainstormed, and they came up with solutions, and then lifecycle assessment was performed for the improvement solutions, and the results are shown in this graph. Okay. Any question regarding this application? So now, I would like to help you with the your project work. So my suggestion is basically use the step 2, step 3, and step 4 using the knowledge base, using the Excel file you have access to. And here, as the starting point, critical design parameters of products and services. I suppose you have some useful outputs from FMEA and QFD. No? So, of course, you are recommended to use the outputs from the other methods. And then once you have these critical design parameters, then you should move to step 3, right? And there are different ways to perform step 3. And the way I explained with the elevator example is a little bit different from what is recommended here. I think this is easier to execute, so that's why I'm showing the this way to perform step 3 here. So, first, you capture important product and service design parameter instances. This was actually step 2, no? Okay, and then identify the class parameter for each instance parameter. Okay, using the Excel sheet. You type in your instance, and then in the next column you choose class parameter. Okay, and then the knowledge base will automatically tell you whether or not there are interdependency between specific combination or no combination, no interdependency. Okay. Then you get the dependencies of the product and service, and then moving to step 4. Suppose you have obtained interdependencies between the product and services. Investigate whether or not the registered cases are useful to your own PSS case. The registered cases are described on a different sheet. It's quite a big sheet, but you can read them. And actually, the 11 examples that I have explained are from those cases. So you could use the 11 cases as a reference also. And then if you find some sort of transferability, meaning that if you think that you can use some of the ideas of the specific case to your own case, then do that and generate ideas for improvement through analogy. Okay? And thirdly, just describe your improvement options. Right? Any question regarding what to do? So basically, as I said at the beginning of this lecture, you are now in the phase of converging design improvement for your PSS offering. And PSS interdependency matrix will help you look into specific connections between the product and services. Okay? And there are full of cases that may be useful for your specific PSS case. Okay? So this is the message. And I should also give some remarks. One remark is related to the second bullet point, meaning the knowledge base is not complete, right? So as I said, it's based on 42 cases that we found in scientific literature. And we don't argue that matrix is complete. So meaning that in the future, some people may find another interdependency. So just be aware of that limitation. And also, you may find an interdependency outside the matrix even. So for example, you may find a service design parameter instance that doesn't belong to any of the classes, and also that applies to another. And even in that case, you may find interdependency between the two parameter instances. It's also possible. Huh? But the use of the knowledge base is recommended because we think that is helpful for you to sort of decrease the design space that you need to explore. So as I said earlier today, it's very much time consuming and inefficient to explore the possible dependency between all the products parameters and service parameters on the instance level. So that's why you are recommended to do that same reasoning on the class level. Okay, so that's the message. Yep. Okay. With that, I'm happy to take any question that you may have. Okay.